Morning class, we are looking at section 2.4, the precise definition of a limit. Okay. We looked at the tangent and velocity problems, the limit of a function, calculating limits using the limit laws, and now the precise definition of limits. So to remind you, we have a couple of things we discussed. We looked at the limit laws. We looked at the squeeze theorem that says if the limit exists when a function is between two different functions, the limit exists for the left and the right side. That means the function on the left and right. Then the limit exists for the function in between as long as the two functions have identical limits on the sides. Direct substitution, basically what we have done, and that's the best course of action, is just to plug in and observe and see what happens. That's what we're doing. And the idea of a one-sided limit, the limit only exists if the left side and the right side will result in the same. Okay, I want to make sure we are comfortable with the concept. Now, this is a fairly short session, so let's put this in slide mode and get things started. First, the idea behind the precise definition. The statement of the limit of f of x as x approaches a equals L has the following precise definition. Given any real number epsilon larger than 0. This is read epsilon, okay? Epsilon. Epsilon meaning a small number. There exists another real number, delta, which is also a positive value. It's a minute number. So that if the absolute value of x minus a is less than delta, then f of x, the absolute value of f of x minus L is less than epsilon. I want to make sure we understand the meaning of this. And first, I'm going to put this format. This is the way I have been always using it. This is completely mathematical definition. And then I want to, dissect the meaning of that. So we're going to read that. Here's how we read it. This is a notation. Okay, let me use a different color for that. And that notation, okay, looks like an upside A, if you will. Okay, that is read in math, whatever. Whatever the value of epsilon, whatever the value of epsilon, as long as it's a positive value, then there exists, now look at this. This looks like an E that has been shifted to the left, okay? There is, or there exists. There exists. So let's read that again. Whatever the value of epsilon larger than 0, there exists a delta larger than 0, such that if the absolute value of x minus a is less than delta, there, then, of course, everybody remembers this one means, this arrow means then. If then, if then. If absolute value of x minus a is less than delta, then absolute value of f of x minus L is less than epsilon. Okay. And this is one version and this is second version. They both mean the same. So the second version reads, whatever epsilon larger than 0, there is a delta larger than 0, that if f of x minus L is less than epsilon, that absolute value, if absolute value of x minus a is less than delta. I want to make sure we understand what this really means. The idea of the absolute value refers to distance. Okay, so when you're looking at this part, absolute value of x minus a means what? Distance. From a. The distance is from a, remember, x is approaching a. So along the x-axis, we are looking at the x distance from a. That means a minute distance, a very small distance from a. Remember, we said this is a. You get to a from the left and right. I'll show you the graph in a moment. Actually, so let me see if I want to go over the graph first. Okay, yeah. Take a look at this concept then. Distance from a. Look at this a, everybody. Okay, look at this a. So this is a. This is a. Now distance from a, that means go on both sides. That means come from the left of a, from the right of a. We are talking about those distances. Distance from the left, distance from the right. So that's what x, absolute value of x minus a, or absolute value of x minus a here is referring to. So if this distance is small, how small is that? Smaller than delta. Okay, this distance is considered delta if it's less than delta. Then f of x minus L, the absolute value of that, what is that? The distance that f of x or the y value has. Let me use a different color actually here. This is the distance that f of x. By f of x, remember, we mean y, right? The y value has from the limit L, distance of y or f of x from L. So I hope everybody can see what we are referring to. This is L, everybody. So it goes up by a little bit, down by a little bit. That means L minus epsilon plus epsilon. This is, if you understood this page, you understand the concept of a limit. The concept of a limit is very simple. What happens when we get closer and closer to A? Along the x-axis. What happens along the y-axis now? If the limit exists, when we approach A from the left and right, then we approach y equals L from the top and the bottom. So left, bottom, right, top. That's the idea. Okay, class? So that's the meaning of this precise definition. All right. Now, so that was the synopsis of that. Let's just repeat that. And I want you to pay attention to the graph and to the top. It says the limit of f of x as x approaches 3 equals 5. What does it mean? It means f of x is close to 5 when x is close to 3. That's simple. This is the best definition one can think of. The y is close to 5 when the x is close to 3. And always remember, f of x means y. So y gets close to 5, x gets close to 3. So whenever x is closer and closer to 3, the y is closer and closer to 5. Okay. And if you look at the graph, just as an example, number 3 here, okay, if you're looking at this one, notice, so we're looking at number 3, we are coming from the left and right. And by the way, as you're coming from the left and right, because this is a linear function, everybody, the left and right have the same really size, delta, if you will. But if it's not linear, they may not be the same, in which case you look at the smaller of the two. But look at what happens. If we are delta away from number 3, distance of delta, we are away from 5 by epsilon. That's the meaning of it. Okay. And that's what you have here, this definition or the meaning that is explained here. So I hope that's good enough. Okay. So when we can make the values of f of x within an arbitrary distance of epsilon from phi by restricting the values of x to be within a distance delta from 3, but not equal, and that's the case. So if x is between 3 minus delta and 3 plus delta, because remember, that's the absolute value class, okay? X minus a is less than, take a look at this one. Okay, I hope everybody remembers how this thing works. It's an absolute value, right? Okay, so that means x minus a is between negative delta and positive delta. Okay, let me actually show that, and then I erase that. Let's use this one. Okay, so if you're looking at this one, what does it mean? I hope everybody remembers absolute value. It means x minus a is sandwiched between minus and plus delta. Now move the a, so negative a becomes positive a, so a minus delta and a plus delta, and that's what we have here for the shape at the bottom right, okay? A is number 3. If you look at the shape, A is number 3. Now the reason I need to erase this because, I need that space. Okay, I need that space. I hope it's straightforward so far. All right, so with that being the case, let's see. What happens next? So precise definition of limit, let f of x be a function defined on some open interval that contains a, except possibly at a itself. In other words, whether the function is defined at a itself is not important. Remember, you're looking at the limit, you're coming towards a, you may never get there. And therefore, a itself is not important, even if the function is not defined. So we say the function has a limit at a, the limit of f of x as x approaches a equals L. It's equal to L if for every small number, small, epsilon larger than 0, there is a number delta. If you come up with a small number epsilon, okay, and then there's a small number delta, okay, both of them are small, such that if absolute value of x minus a is between 0 and delta, okay, or it's just less than delta, that means distance from a is less than delta, then absolute value of f of x minus a is less than epsilon. That means the distance of the y coordinate, the limit from a is less than epsilon. So take a look at this shape. If you look at the left side, if you look at this one, class, okay, x in the vicinity of a, so here's a and we are in the vicinity of a, close from the left or right, then somehow we get close to L along the y-axis, okay? But we never remember, we never get to A, we never get to L, okay? We are close, and that's the concept. And that means also here, take a look at here. Here's A number 3 within delta. Then we get to the limit 5 within epsilon, okay? That's the idea, class. I hope it's straightforward. So take a look at a simple example. This is what I want you to get. It says use the graph to find delta such that when the absolute value of x minus 3 is between 0 and delta, absolute value of f of x minus 2 is less than 0.5. And so I'm writing the definition, whatever epsilon larger than 0, there is delta larger than 0. That means whatever a number epsilon, whatever the number you pick, as long as it's a small number, but it's positive, like 0.1, 0.2, 0.001, that's the idea. Then there's a delta that if absolute value of x minus a is less than delta, the distance is delta. So this distance, we are looking at this distance, class. This distance This considers the distance from what? Distance from A. In this case, A, everybody, A is number 3. So distance from A to the right and to the left, those are called delta. Now, what is the limit? The limit is 2, so within what? 0.5. Notice this up to there. In other words, this is 0.5, this is 0.5. Now, I went through the process, but even without the process, I hope you see the concept. The concept says, okay, we know this, everybody. We know this is 0.5. This is 0.5, and you can see it. This is 0.5, and you can see it. Okay, and this is your epsilon. This is your epsilon, everybody. This is your epsilon. Fine. Epsilon is about 0.5. By the way, 0.5 is fairly large. I want you to know that. Okay. But anyways, it's 0.5. Then what would you choose as your delta? So I hope you see that the delta, they have really, if you look at number 3, the distance from 3 to 3.8, that's one choice. That means 0.8. 2.6 to 3 is another choice, which is 0.2. So if you have those two choices, let me just discuss that from the point of view of the graph so you can see that. If you look at this distance, class is 0.2. If you look at this distance, is 0.8. So this is 0.8. And the other one is 0.2. I hope it's clear. I'm sorry, 0.4. 0.4. This distance is 0.4. 3 minus 2.6, 0.4. 3.8 minus 3.8. So those are the values of delta. Now, use the graph to find delta such that this thing works. Now, imagine there are two numbers because they're not different. Imagine you choose either 0.4 or 0.8, which one and what. Let's choose 0.8. If you choose 0.8, it works out for the right side. Okay? But if you choose it for the left side, that means 3 minus 0.8. Okay? That means 2.2. So somewhere here is 2.2. And when you go up here, it takes you there. You're not within the epsilon. That doesn't work, class. So what does it mean? It means if the delta is the same on both sides, that's your choice. If it's not, then you choose the smaller of the two. Otherwise, it doesn't work. Again, if you choose 0.8, does it work for the right side? Yes. Does it work for the left side? No. If you choose 0.4, does it work for the left side? Of course. Does it work for the right side too? Yes. It's within that 0.5. And that's the idea. So the process is start with f of x minus L less than epsilon, and you know that it's already there. For a shape, for a graph like this, you don't even have to do that. So the meaning of this ultimately gives rise to this. Okay, this is based on using absolute value. Okay, so f of x, as you can see from the graph, is between 1.5 and 2.5. So what about x? X between what and what? Okay, can it be between 2.2 and 3.8 or not? That's the ideal, and the answer is no. It's between 2.6 in essence and 3.4. So you want to look at the graph. Okay, this is what we have, but ultimately, and this one is 2.6. Okay, we have to calculate the delta. There are two different values. You go with the smaller of the two. Okay, I can't emphasize this enough. Any smaller number will do. And that's another thing. When we say, here's the value of delta, any number less than that will also do the job. Okay? Any number less than that will also do the job. So a fast and easy way to do this question, take a look at the graph and take a look at the distance from 3 and pick up the smaller. Now the rest is just going over the explanation. All right. Let's look at a couple of examples, and the way the proof goes, at the very least, you're exposed to some for the sake of your homework. As far as the exam is concerned, I'm mainly interested in the first half. First and foremost, I have at the very top the definition. The definition is whatever epsilon, the choice of epsilon, as long as it's a small number larger than 0, then there must be a small delta. Delta is larger than 0 also, a small number. If absolute value of x minus a is less than delta, then absolute value of f of x minus l must be less than epsilon. And that's really the idea we need to understand and follow. Okay. By the way, I just want to make sure that we understand, if I didn't mention this, this is read such that all right, so let's get started. The very first step is absolute value of x minus a is less than delta if f of x minus l is less than epsilon. Let's just plug in. So x is x, okay. A is what? Number 3, okay. F of x is 4x minus 5, and L is what? Number 7. So let's just replace it, okay. In other words, in here, this is your f function, and this is your limit. So let's plug it. Now, that's the first thing. This is the write out to get us started, okay. Now, the process using the if-then is to start with the second portion and get to the first one. In other words, this is what you start with. And then you want to end up here. And so what happens is that in this process, you will get the left side, which is absolute value of x minus 3, and the right side will be the relationship between epsilon and delta. Okay. So start with that. 4x minus 5 minus 7 is 4x minus 12. Here. Everybody can see we can factor out the 4. And everybody can see we divide by 4. Okay? Because remember what we want to do. We want to compare and make a decision. So if you divide this by 4, okay? So we are going from here to here. And division by 4 gives us epsilon over 4. Now compare this to absolute value of x minus 3 less than delta. Therefore, the choice of delta must be epsilon less than 4. What does this mean? I want to make sure we understand. According to this calculation says, whatever you pick for delta, I'm going to make it up. Let's say your choice of delta is 1, and 1 is huge, you shouldn't be, but just for the sake of argument, 1. If your choice of delta is 1, then what should be, my apologies, epsilon is 1. What is your choice of delta is 1/4 of that, okay, 0.25. So whatever you choose, as long as you divide that by 4, becomes the choice of delta, all right? So that's how you choose whatever epsilon. So let's go back to the very top. I want everybody to see the very top class. Take a look at this one. Take a look at this one, class. Whatever epsilon is larger than 0. Okay. Choose any epsilon you want. There should be a delta larger than 0 that this thing will work out. Okay. Whatever the choice of delta, epsilon. So what did we decide? Okay, let's go here. We decided delta is epsilon divided by 4. What does that mean? Whatever the choice of epsilon, things work out if you divide it by 4 and you get delta. So if f of x is within epsilon, okay, of the limit, within 1 unit, for example, from the limit, then along the x-axis and close to a should be within 1/4 of that, 1/4 of 1 or 0.25. Then it will work. That's what it says. Whatever the choice of epsilon is, there is a delta. So if whatever the choice of epsilon, you have to figure out what is their relationship. Okay? The relationship is that epsilon divided by 4 is equal to delta. This is the relationship you figure out. Practically, you're done. We worked our way back, okay? So proof. The proof, and you really have to do a couple of examples like this for the sake of homework. As far as the exam, I haven't asked you a question like that. But here's the reverse process. And the reverse process basically being this, okay? You are going to work your way back. You start from here, class, and you work your way back, and you get to this. Take a look. So we're going to go now from here to here to show it works. So therefore, sometimes you have to get creative, and the way you get creative is very simple. Take a look at the steps that you took to come here. Now you take the steps back to go back. That's the concept. So let's take a look at this one, okay, and see how it works. Okay, so given epsilon larger than 0, choose delta to be epsilon divided by 4. That is the choice based on what we got in the previous step. Okay, so now we are going to start with this, okay? Absolute value of x minus a is less than delta. In this case, absolute value of x minus 3 is less than delta. So we start with this, and what is delta? We said epsilon over 4. So we start with this, we want to go there, and to start with that, okay? We remember that delta is epsilon over 4. Okay, let's multiply both sides by 4. Remember what we are going to do. We are in essence here, everybody. So we want to work our way back. We want to work our way back. So we are going to reverse the process as far as the. So you multiply both sides by 4. Okay. You put the 4 in. Okay, class. And it's 4x minus 12. Now I'm going to go back up and show you 4x minus 12 here, class. 4x minus 12. Let's go up. Let's go up. This is 4x minus 12. So I want you to see that you got this far. Now, what is your next step? We are going back. We are going back. Here's the trick. We know the two are the same, so we're going to write it this way. Okay, so here's the next step. You write it this way. So what is 4x minus 5? F of x. What is minus 7? 7 is the L. Okay. And in essence, we are showing that if absolute value of x minus 3 is less than delta, then 4x minus 5 minus 7 is less than epsilon. And that's the proof, the end of the proof that the limit, what was the limit? Take a look at the top one. The limit exists and it's equal to 7. So what am I saying? The limit, okay, so this is what we get. The limit of absolute value of 4x minus 5 when x approaches 3 is 7. Okay. This is not an absolute value class. This is, let me just fix that. Okay. This is like, I want to make sure that we are comfortable with that. Okay, class. Okay, just fix that and we're going to move on. Here's the next question we're going to look at, everybody. I'm choosing something that is a little bit more involved. And again, remember the process. The process is to just find the relationship between delta and epsilon. Number one, your f of x is 9 minus 4x squared over 3 plus 2x. Number two, x is approaching a, which is negative 1.5. So let us write, let us write this, and then this, where a is negative 1.5, and here's your f of x. Here's your f of x. Let's do that. Okay, we want to do the write out. X minus negative 1.5, which means x plus 1.5. Everybody knows that. Okay. And then this is the case. So what we have to do, we are going to start with the second part. We're going to start with this, everybody. We're going to start with this. And by the time we're done, the idea is to start with this and get to this, x plus 1.5. This is the same as x plus 1.5. And this is according to what we see on the right side is epsilon. So that gives us the relationship between epsilon and delta. And when we're done with that, practically we are done. And then we reverse the process step by step. So let's start with that part. Okay. Now everybody knows we can factor the top. It's a squared minus b squared equals a plus b times a minus b. So everybody can factor it. It's really not a big deal. Okay. So when we factor this, everybody, 3 plus 2x, 3 plus 2x, and 3 plus 2x cancel each other. And we are left with the numerator only, 3 minus 2x, and then minus 6. So 3 minus 2x minus 6. So hold on to that. Eventually, we're going to come back. It's now simplification of that. See what happens with the simplification of that. 3 and negative 6, they add up to negative 3. If we factor out the negative 2, remember, we are getting here, we want x plus 1.5 plus, or 1.5 plus x, whatever. X plus 1.5 or 1.5 plus x. So if you factor out the negative 2, you get that 1.5 plus x. And then divide both sides by the absolute value of negative 2. Now class, what is absolute value of negative 2? That's 2. So you divide both sides by 2, and now what did we get? Epsilon over 2. So what I want you to do, I want you to compare this one, everybody. Compare this one. 1.5 plus x less than epsilon over 2 to this one, to the very first one. X minus 1.5 less than delta. I hope you see they are identical. That's x plus 1.5. That's the same thing. So delta must be the same as epsilon over 2. So that would be the choice. What do you choose? How do you choose? You say delta from here, this delta must be equal to this value. So the choice of delta is epsilon divided by 2. Practically, you're done for the exam, you're done, but let's see how the process works. Let's just quickly finish that. And to finish that is to reverse the process, meaning class. We're going to start with this and take a look at what we are heading. We want to get there. We want to get here. To get here, the only way is to go back. Reverse the process. Reverse the process, class, okay? And because you know you reverse the process, the tricks involved, you can see them. So one more time, when you come this far, your next step for the proof is just reverse. So from here, you go here, here, and this is what you have. So let's see, quickly show that, okay? So given epsilon larger than 0, the choice is delta is equal to epsilon divided by 2. So that would be the choice. And so this is how we choose that, okay? So we have that so far. Let's start with this part. 1.5 plus x is less than epsilon, okay, divided by 2. So delta is the same as epsilon divided by 2, okay? So we're going to multiply both sides by 2, and then take out the 2 is the same as absolute value of negative 2, okay? Now, if you multiply both sides by 2, class, is the same as absolute value of negative 2. So again, why are we choosing absolute value of negative 2? Just go back. The process was, take a look. We chose what? Negative 2, the same as 2. So you're using 2, the same as. Why are you using that? So you can end up here. And notice you do end up there. Okay, so you are here. We are continuing with this process. So minus 3 minus 2x is less than 2 delta, which is the same as epsilon. Okay, less than 2 delta, which is the same as epsilon. And so what is the next process? Okay, so we are here, class, we are here, which is the same as here. I'm going back, I'm looking at this one. Okay, it says this is the same as this one, right? Okay, so let's make it look like that. We can look at what I did. So minus 3 minus 2x is the same as putting 3 here and negative 6 there. So I'm going over here, class. I'm going over here. I'm reversing the process. Why am I choosing it in this way? Because that negative 6 must be separated, because that 6 was the limit and we are going to keep it intact. Now 3 minus 2x, just this part, 3 minus 2x, okay? Remember what we want. We want the top to be 9 minus 4x squared, so it requires to be multiplied by 3 plus 2x. So I can look at this one and say I'm going to multiply it by 3 plus 2x. To undo it, I'm going to divide by 3 plus 2x also. So take a look. So 3 minus 2x and 3 plus 2x. Okay. So we have that. And now notice what happens. You replace that with what? You replace that with 9 minus 4x squared. So we are here, class. This one is the same as this one. Okay. And believe it or not, in essence, this is the end of the proof. So the proof says, when you start from here, take a look. When you start from here, that means here. Okay, so if remember x minus 1.5 is the same as 1.5 plus x. If, then, this is the result, right? Then, if, then, we prove that. If, then, that means the limit exists. And so the limit of that expression is equal to 6. Now, this second part you want to practice a little bit, but it's the first part that is extremely important to me, and I want to make sure that you can handle that when you see your exam. I'm going to get one more example, and that's it. There are some more examples. I put it in the PowerPoints. You can look into it yourself. Let's look at something slightly different. Okay. Again, the definition for one-sided limit is given in the following manner. If whatever the choice of epsilon larger than 0, then there must be a delta larger than 0. That if x, this is one-sided. if x is between a and a plus delta, then absolute value of f of x minus l is less than delta, because this is 0 from right. If it were 0 from the left, you would put here a minus delta less than x less than a. Okay, this would be it. So that's the concept. All right, so let's do the write out. Okay, remember when we look at this one, okay, your a is 0, and so is the limit. So to do the write out, it looks like this. If x is between 0 and delta, okay, if x is between 0 and delta, and we are looking, just look at this one, okay, then absolute value of f of x minus l is less than 0. Now, what is a, everybody? A is 0. So remember, this is what? 0 plus delta. So you can think of this, let me just write it maybe at top of it. So this one is a plus delta, a plus delta, and a is 0. And then, of course, this is L, and L happen to be 0 also. Okay. All right. So that means we are going to start with absolute value of f of x minus L, which means we are going to start from this guy. So absolute value of x minus 0, absolute value of square root of x minus 0 is less than epsilon, or simply put, square root of x is less than epsilon, and you can square both sides. And now if you compare, if you compare this one, x is less than epsilon squared. Compare this one, x is less than what? Delta. So put this next to this, and that gives you the relationship between the right side, delta and epsilon squared. So simply put, what would you choose? What would you choose for delta? Delta should be what? Epsilon squared, that's all. So delta should be epsilon squared. If you can come this far, pretty much you're done, class, okay? Pretty much you're done. And that's really important to see. And so rewriting the reverse process. So given epsilon larger than 0, the choice we said is delta is equal to epsilon squared. So with that being the case, let us write this one, okay? Let's write this one. 0 is less than x, less than delta. And what is delta? We decided delta is going to be epsilon squared. Okay. Now let's square. Because this is epsilon squared, let's take a square root. So take a square root. And when you do that, square root of x, and by the way, all of them are positive. Epsilon is positive, delta is positive, all of them are positive values. There is no plus minus, okay? So square root of x is less than, square root of delta is less than epsilon squared. And epsilon squared, when you take a root, gives you epsilon. And that's practically this result that we have. And so we are going to write it as this result, okay? Absolute value of square root of x minus 0 less than epsilon. Which means now, going back, starting with this is what we started, we are going to write it here, if. This is the starting point. Then, here's the ending point, here's the result. And the whole thing together is what we started here. We just showed that, the reverse process. And therefore, the limit of the square root of x as x approaches 0 from the right